Today's lesson is objective number 12, explain evidence for seafloor spreading from both igneous ocean rocks and the reversal of magnetic polarity. Remember, at any time you can pause the video if it's going too fast. So at this time, pause the video and copy down objective number 12 on your objective page and put tomorrow's date, since we will be discussing it tomorrow. Alright, so there's plenty of evidence to suggest that the ocean floors are spreading apart. The two main pieces of evidence are found at the mid-ocean ridges, which are at the bottom of the ocean. Those two main pieces, as you copied into your objective, are the age of the igneous ocean rocks on the bottom of the floor and the reversal of the magnetic polarity that is shown in those rocks. And to show an animation of what this ridge looks like, if you look at the top left, you can see the animation where you can see inside the earth this hot magma that is coming up. Right? As it comes up at the ridge separates. That causes movement to the right on one side of the ridge and movement to the left on the other side of the ridge. Also, if you look at the rock that is being formed, you can see patterns in the rock. Right? You can see dark bands, right, that are being formed as well. Right? And this rock is found at the bottom of the ocean floor. Okay, so what about the rock at the bottom of the ocean floor? It is an igneous rock. It is basalt, which we had discussed when we were doing igneous rocks, as a mafic type of rock. It is formed when that hot liquid magma, that molten rock, rises from the center. As it comes up, it will cool. It will then solidify, turn into solid, and form crystals that are indicative of igneous rocks. When scientists analyze these rocks, what they do is they start from the top of the ocean and they drill down into the bottom of the ocean floor to pull up those rocks, and they can analyze the age of the rocks. And what they find is that if you are really close to the center of the ridge, like for example this X right here, right, when they find the age of the rock, they notice that it is young compared to point Y way out here. They find that the rock is older. So the further they get away from the mid-ocean ridge, the older the rock is. Now what is interesting is they can also go on the other side of the ridge over at this X, and they also find that the rock at that X is young, right? And as they get farther away, they find that it is older as well. So they see a pattern on either side of the mid-ocean rock, or mid-ocean ridge, excuse me, right, where the rock is younger at the center and older the further away you get. Now, how do they do this? How do they find the age of the rock? They use something called radioactive dating. We will discuss that in Unit 5, so we're not to that right now. Right, but what this suggests is, since we're finding the young rock close to the center, it suggests that the magma is coming up, and right at the ridge is where there is volcanic activity and new ocean rock being formed. And that is being pushed further away. So when you get way out by letter Y, that rock is older because it was formed at the ridge a long time ago and now has been pushed further and further from the center of that ridge. So that's how the age of those rocks helps support the idea of seafloor spreading. The second piece of evidence is the reversal of magnetic polarity. So what they do is they again analyze the basalt, or the basaltic rock, that is found on the bottom of the ocean, and they look for minerals, magnetic minerals that are in the rock, and it shows them patterns of reversal on either side of the ridge. These patterns of reversal suggest that the North and South Pole have switched their polarity in the past. Right, let me show an animation of how they come up with this. Okay, so if you look up at the top left, what you see is the boat that is trolling along the top of the ocean. Right, and they are bringing an instrument behind them where they're analyzing the rock on the ocean floor. And what they see is that when they look at a mid-ocean ridge, all right, at the bottom of the ocean floor, I guess that blue mark isn't necessarily a mid-ocean ridge, but when they look at the bottom of the ocean floor, what they see is the rocks on the bottom have minerals that are either pointing towards the North Pole or currently towards the South Pole. And in this animation, they're trying to show that in red and green colors. So they're taking this data from the bottom of the ocean floor. Now what does that mean since they see the two different colors, the two different patterns? How do we get that? Well, when the basalt flows up from the center, the magma, right, it's liquid. So any minerals that are moving inside of that, right, magnetic minerals have ability to be fluid. They can move. So just like the needle of a compass, those metallic or magnetic minerals can point towards north. And then once the magma solidifies and hardens, those minerals can no longer move. It's like they're frozen in concrete. Right? It's actually just like concrete, as if somebody was pouring concrete sidewalk near your house. And when it's liquid, you can put your hand in it and you can write your name in it. But then once that concrete hardens, it is locked in place forever. Well, that's the same thing with the magnetic minerals in the rock. When it's magma, they can come up and they can point towards north, just like the needle of a compass. So in this diagram at the bottom, you can see the magma coming up. And in this particular picture right here, all the yellow rock represents minerals that are pointed towards the North Pole. Well, then what scientists believe is seafloor spreading. As you can see the big blue arrows going to the right and to the left, it is going to pull at that ridge and separate those rocks and take those rocks further and further from the ridge. Well, then at some point in the past, the North and South poles reverse their polarity. So now when the magma comes up, look in the second picture, right, now the minerals are not pointed towards the North Pole, they're pointed to the South Pole, the exact opposite direction. Right? And what we saw before is the rocks that had minerals pointing towards the north are now split and pulled away from the ridge, and now new rock is being generated there. And this has happened numerous times in the past. So if you go down to the third and final picture, where you can see the magma coming up, again, north is what we currently consider north. So the rock would look in this particular diagram yellow. Right? It's not really yellow, it's black basalt, but the yellow is supposed to represent minerals pointing towards the north. And what you see is if you go on either side of that ridge, you see rocks pointing towards the north, minerals pointed towards the south, minerals in the rock pointing towards north. Go on the other side, you see minerals pointed towards the north, you see minerals pointed towards the south, and you see minerals pointed towards the north again. So you see the same exact pattern on either side of the ridge. And say, why do we see the same exact pattern on either side of the ridge? Well, again, it supports the idea that those rocks are being made at the mid-ocean ridge, being pulled out each direction, right? And again, it supports seafloor spreading. Same exact pattern on either side. And here's just an animation to show you. See the red arrow of the magma coming up, right? And as it comes up, it makes rock. But if I can push on the button on the right and I can flip the north and south pole, you will see a pattern. Every time I flip, 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 flip. Every time I flip it, right, you're seeing rocks that are pointing in a different direction. Well, as this animation, instead of being yellow and red, it's gray and like a, I don't know, deep brownish, purplish. Right, but you can see as I do this, and I keep hitting flip, 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 you see the same exact pattern on either side of the ridge, pushing out to the right and to the left. So because it's the same exact pattern, it suggests seafloor spreading at the center. And that is the end of objective number 12.